So we are ready to go with the next session. It will be, this topic is called Callbacks to Async Awaited Node.js and Build Your Own Promise. Our speaker is Tamar Twena-Stern from XM Cyber. Welcome, Tamar, to the stage. How are you?
I'm great. I'm really excited to be here. Actually, this is my first online conference. I've done a lot of conferences which are not online.
Yeah.
This is my first online conference, so I'm very excited of the occasion.
Good luck then. So I'll be here. I will keep an eye to the audience. We can have some chats here, and on our YouTube channel, I'll bring you some reactions from the audience from time to time. And just keep going. I'm here with you all the time. Good luck.
Thank you. So I will start now, and I'm sharing my screen.
Brilliant. Yeah, I can see your screen.
Okay, everyone can see?
Yep, the screen
okay.
is going to the screen.
So, hi everybody, and as I said, I'm very, very excited to be here. And my name is Tamar Twena-Stern, and welcome to my session. So I'm writing in Node.js for quite some time, for several years, and I remember very well the callbacks period. So we are going to talk about the transformation of the code from callbacks to async await, and about promises and what is a promise. And at the end, we're going to show a small implementation of a promise. We're going to do some performance measurements in between. But, let me start with telling a little bit about myself. My name is Tamar Twena-Stern. I'm a software engineer, and I manage a large team, and I'm an architect. And currently, I lead the backend in a company called XM Cyber. We are a startup in the cybersecurity field, and we are really cool. We're simulating a hacker, and we're hacking to your computers. We're doing a defense by offense. And another thing that I can say about myself is I was a CTO of a startup of my own. And my passion about Node.js started when I founded my own startup, and I have wrote the entire backend from scratch in Node.js, and then I started to get really deep into that technology. And you can all follow me on Twitter. So some stuff that I would like to tell about myself. So I have 3 kids. And the smaller one is 1 year and 3 months old. I'm a community leader in JavaScript Israel, and this is the largest JavaScript meetups lineups that we have in Israel. And I'm also a professional violin player, and I'm a code writer, of course. And let's just start to get into business, and let's talk about what is blocking I/O and what is non-blocking I/O, and that would fit really into our conversation about why callbacks are used in JavaScript. So in most languages like Java, C#, Python, so in those languages, what's happening is that when we're doing an I/O operation, such as a database query, such as an HTTP request, so we are waiting for the result. And that makes a lot of sense because usually wants to do something with the result in your code. But in that approach, in order to handle a lot of requests, we need to open a lot of threads. And each thread is coming with an overhead of memory, of CPU, of engines. And that's really in high level. And also a lot of times you also open background threads. So in that case, when the system is stressed and you have a lot of work, so you have a lot of context switching to do. and the context switching starts to take a lot of your CPU time. I don't know who of you worked with thread, but it's usually that like you add a lot of threads, and at some point, you know, you're working with 100 threads, and then you're working with 200, but you see that the performance are not improving, and there's even a degradation. So that is the reason for that. So as I said, so this is the problem. So when the system is stressed, actually the system is doing a lot of context switching instead of doing actual work. So Node.js is working in non-blocking I/O. Non-blocking I/O means that while you're waiting for an I/O operation, which is heavier than regular memory operations, you can do other stuff. And for that, the mechanism of event loop was designed. Event loop was in JavaScript in the browser from the first days of JavaScript. And then it entered the architecture of Node.js. So really in high level, when a new request is coming to your Node.js server and a callback is being registered, and after the registration of that callback, the event loop starts to execute all those callbacks. And when it has I/O operation, it offloads it to another component called the worker thread pool. When it's doing that, so after that, when the event loop is actually, when the operation is over, the event loop is getting a signal that the operation was over. And in that case, the logic that has to be executed after the callback is finished is being executed. And in that case, you're doing much less context switching, but that takes us to a pattern called asynchronous programming. So since synchronous operations are blocking the event loop, the JavaScript has implemented callbacks since the beginning. So callbacks in JavaScript are first-class citizens, and there was no return value, only callbacks in the earliest days of JavaScript to support asynchronous programming and non-blocking I/O. And this is how asynchronous code looks like. It looks like, let's say here we have a model and we're doing save. And then if there is an error, we're returning an error. Otherwise, we're doing success. But you're seeing this code, everything is callbacks. So now we're asking the question, why callback programming is so bad? Why is it so bad? Well, I would like to introduce you this. That is called the pyramid of doom. And that is like callback from callbacks programming hardcore. And you see that from those callbacks, it is really, really hard to read the code at the end. You don't really know what is the flow. It is really, really hard to understand the flow. So that's what this callback programming has created. Another thing which is interesting here, and I don't know if interesting, but it's easy to miss, is error handling. You're seeing here, well, if there's an error, we are returning the callback with an error. So the caller would know that there was an error. But here, there is another error that's hiding here in the JSON parse. Okay, JSON parse can also throw an error. And that can be a problem, and that code would just crash and crash with an error, and that code was not written well. So here is what we had to do here with the JSON parse, and that is a way that callbacks programming is making us make it easy to miss those errors and handle them. And another thing which is really, really hard to implement here is to implement control flows. I mean, if we want to do something serial, meaning to do one action after another and make sure that nothing would get in between. It's really, really hard to implement it with the callbacks, and also parallel programming is really, really hard. And these are capabilities for flows that we need in our everyday programming. These are very, very important. And after all of that, promises have come into the JavaScript and into the JavaScript world and entered into Node.js. And that was entered actually to make life of the developers easier and to make the code look readable and to reduce the nesting levels. So what is a promise? A promise is actually a proxy for a value that we don't know yet. I mean, when we execute a promise, we don't know what the value would be. So I guess most of you are writing with async await right now, but in promises programming, you can register a handler to a success operation. You can register a handler to failure operation. And so that is what you're doing. And a promise is an object that it has states. Okay, a promise starts in a pending state, and then after it's being executed, it can receive one of these two states. It can be fulfilled or rejected. Okay, so these two states, fulfilled or rejected, are the final state of a promise. It's just came from, like, I think the manner of speaking of the promise is kept or the promise is broken. But yeah, if it's fulfilled, if everything is good, then there is a value that we return. And if it's rejected, then usually we are returning an error. So the promise code here looks much, much better and much less nested than the callbacks code. If we were talking about the pyramid of doom, then right now with promises, the code looks much, much, much better, and we reduce the level of nesting to only one level, which makes the code much more readable and much more easy to write. So I would like to talk about promise libraries. So we have a promise, we have native promises functionality in ES6. And there is Bluebird also, which adding a lot of extra functionalities that usually ES6 promises doesn't add. But it adds a lot of capabilities that the ES6 native promises doesn't give you yet. So after we spoke about that, I would like to measure some performance of promises, and I would like to do a little bit of trying to compare between the Bluebird promises and the native promises. So why am I doing that? Why I would like to compare? I'd like to tell you some history, because in Node 7 and Node 8 versions, so Bluebird promises were much, much faster than the native promises. Okay, so I got like a lot of time differences that were like twice faster. Like Bluebird was twice faster. But I would like us to measure this, and I've lectured, like, I think in 2 years in a conference, and I've shown that in Node 8, well, Bluebird is much, much faster, but things have become a little bit different now. So I would like to open my VS Code. Hey, here it is. And I would like to show you some code. And I would like to do it in, well, let's see, what's my current version? So my current version is 10. Okay, and I have here 2 scripts actually. I will just open them one next to another, and we'll just look at them. So this script is working with Bluebird promises, and what we're doing is we are resolving, I think, around 1 million promises, and the executed code that the promise is doing is something really simple, which would not affect performance. And then this used the native promise, okay, the native promise of the language. And okay, so I hope that everybody is seeing my console, but here we're doing the same task. We're running 1 million of promises, and we're gonna see how much it's going to take to do the resolve here. So I really hope everybody could see my terminal well. Here, I will just do it in VS Code. And let's do Node Bluebird. Okay, so we've got around 1 second. And let's do Node native. And we're going to see what we're going to get. Okay, so I have to tell you that in Node 8, the time difference was like twice. It was like 2 seconds vs a second, and Bluebird was a clear winner. But in Node 10, we have a time difference of 200 milliseconds, which means that native promises are much, much faster. I mean, I know that the Node core team are doing a lot of work in that area to make native promises much faster. And then I would like to do, I hope that all of you are familiar with NVM. So I would like to switch version with my NVM, and I would like to do NVM use. NVM is a tool that helps you work with multiple node versions at the same time in your computer. So I would like to do NVM use this version 12. And it's interesting to see what was the improvements in version 12. So right now we're in version 12, and let's do right now Node Bluebird. Okay, and then we'll do Node native. Okay, so this is interesting. This is Bluebird and native in version 12 of Node is quite the same, and native is even winning in performance-wise. All right, so Bluebird is 1.16 seconds, and my test in native in version 12 is 1.1 seconds, which is quite an improvement. So I would like to say that when I lectured about performance in previous sessions, I said use Bluebird, but you know, the performance work of the Node team like really increasing. So right now I'm saying if you're choosing a library, go with native promises. Well, because that is like I think that the promise library that would be most invested. And you know, if they're beating Bluebird in performance, I guess that the Node core team would like beat them in the future with functionality and would add more functionality. So that is really, really good to know. And if you would combine Bluebird, it might be that it would be hard for you to get rid of it. Another thing that I would like to say that I don't know if you're familiar with async hooks, but I've done this test with async hooks, and with async hooks, the native promises, I mean, with async hooks enabled, the native promises are much slower than Bluebird. So that is another consideration. But right now, if you don't have async hooks enabled in your system, I really prefer to go to the native promises and not to Bluebird. So that's what I had to tell you about async await, about promises. And now we're going to go into our next phase, which is async await. So what is async await? An async await is a syntactic sugar, I have to say, that entered our language in ES7. And it is only gives you the ability to write promises in a more readable way, as an async function is just a wrapping of a promise for a function. An async function returning a promise, and within a wait, you are waiting. For the promise. So that makes the code look really clean and concise, but behind the scenes, although it looks like you're writing the synchronous code, behind the scenes, everything is asynchronous, as we saw in the beginning. Everything is asynchronous. Everything is working with asynchronous operations. That is an async await code. Async await code, as you can see, is much, much cleaner. It's much easier to understand. It looks like a code that you write in Java. So how that improved the situation? First of all, there's no nesting right now. We don't need to write with the nesting, and we don't need to register any anonymous callbacks, and we're not creating a variable of all those variables that we don't really need, and all of this stuff. So that is cool. The error handling is much cleaner. Look at that example that we've seen in the beginning of the lecture with the async await. Right now, we're handling the error in one place, one unified place. There's no like hybrid handling, and that is very, very good. We don't need to transfer intermediate values, and that is also very good, makes the programming really, really simple. And executing stuff in parallel has become much, 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 this has become much easier with Promisal. So that really improved our life as developers. So I would like to just say my opinion about promises. A lot of people see in promises syntactic sugar, and I don't see them syntactic sugar. I don't think that promises give syntactic sugar. That's my opinion. Async await is pure syntactic sugar, in contrary to promises. Async await is just a better syntax for writing promises, but promises gives another functionality. So we spoke about the object being the state of the object. We spoke about that it starts with pending and then it gets a resolve or rejected. And it's actually helped me to save a value. So I have succeeded to implement a cache initialization with promises, and that helped me, like that functionality of promises helped me in first initialization. So if you're implementing a memory cache for some reason, and you want to make sure that a value would not be initialized twice, then use promises and save promises. So that would help you a lot. Right now, I would like to speak about another problem, which is created by the fact that the code is very, very, very concise and clean. I mean, the code with promises is very neat, no nesting levels, and it is misleading because we are actually thinking that the code that we are working on is actually a synchronous code, okay? And when we're thinking that this is a synchronous code, we don't get the time to understand the architecture and understand that we're working with asynchronous operations and with non-blocking I/O, okay? So we can miss the biggest advantages of Node.js, which is non-blocking I/O. What does that mean? So In Node.js, we are getting an advantage if we're running stuff in parallel, okay? But if we're running it like really with async await, and we're doing one action after another, we're executing one operation after another, then we're creating patterns of serial code that in real life does not perform really, really well. What do I mean? Okay, so look at this code. This is like, that's called actually sequential IO. So let's assume that get users is doing DB query to users, and get categories is doing DB query to categories. And then we're returning both of them. But you can see that users and categories are not dependent at all with one another, okay? So we can run both of them in parallel, and we can actually use promise all. And with promise all, we can run them in parallel and get better performance. So I've prepared a really small demo for you, so you would actually see that you know, that can help you save some time. So I would go back into my VS Code, and I would just open the second demo that I have prepared. So that is the demo. Now let's go over it real quick. All right, so let's see what is going on here. So actually that is an Express server, really simple Express server. I hope that everybody here is familiar with Express, and I don't need to get into that library and explain about it. And I have here too, that is actually written in MVC pattern. Which I have a model which is maps to a Mongoose schema, and I have a person, and I have two entities here. I have an entity of a person and an entity of a pet. Okay, so that is the Mongoose model of the person, and that is the controller, sorry, that I have. And that controller, I'm creating person, and I'm just saving it, and I'm giving it my name. And here I have another thing, and that is a pet. And let's say that the pet has a name, and also that is the model of the pet, mapped to Mongoose. And this is a controller, and here I'm creating dogs. And then let's go to the server itself. Cool. So let's go to the server itself. So that server is actually exposing, wow, that's embarrassing. So that's actually exposing one route with a slash, and that is the parallel server. Here I'm working with promise all, and I'm creating, I think, 8 entities in parallel. And here I am working with a serial code, and I'm creating 8 entities, one after another with a wait. I'm like waiting for every entity to be created. And that is, as you can see, those calls are not related to one another, and we can work with them. So I would just hope that all of you have enjoyed the code. So I would go to my terminal, and what is this?
Tamar?
So yes.
Yeah, I'm here to remind you that we have 5 more minutes.
Oh, we have 5 more minutes.
Yeah, and then we'll be moving to the Q&A session. I shared already the URL.
Okay.
Is that clear?
So I would just like to really show you the code. We would go into here, and then we would do just a sec. Yeah. Then we would run this. Okay, so that thing is working. And now I would like to share with you a tool called AutoCannon. And AutoCannon is a tool that is helping me to bombard my server with a lot of requests. So I would go into the next tab, and I would like to send a lot of requests to my server. And let's see, it's running. So right now it's running, my server is processing it. And all right, let's see what we have here. So first of all, I would just want to say that when we're measuring performance, we need to look at the latency, and we need to search for the larger percentiles. Here, the percentiles of requests in the 97th request was around 41 milliseconds. Okay, and we have succeeded to process 52 requests per second. And why it is important, because usually when you make a commitment to a client of how fast your request would be, you're doing it by the larger percentiles. So then we would just stop this, and then we would do node we would just run this, and we would see the code runs in parallel, and we can see the improvement. We would wait a second. All right, so let's see at the latency. Look at the median here was 10 milliseconds, and here the median was 16 milliseconds. This is a huge improvement for the parallel code, okay? And here the 97th percentile is 41 milliseconds, and here is 32 milliseconds. And we have succeeded to process, let's see, requests per second for 72 vs 52 here. So we're seeing major improvements. So just remember, all of you, if you have calls which are not really dependent on one another, always just search for those patterns in your code and work with promise all, because in bigger projects, those things count. Do we have time for 1 minute to see the promise implementation?
Yes.
Or we don't have? If we don't have, I can show it in the Q&A room.
Yes, that's fine. We extended up to 3 minutes more.
All right, so I would just, let's show the promise implementation itself that I would like to show you. So if you have wondered how to write a promise, okay, in JavaScript, I have to share with you one more thing. So promises in Node.js are written in C and C++ in the core, just to make them much more efficient. But let's look at a simple promise implementation. So that is our class. We have a constructor. It receives some function, an execution function, and then we're just we have to implement resolve and reject, and when we're doing it, we have to bind it to the context of that object. That is important. That is the then function, and then we have here a promise chain. That promise chain is for cases of then, and then we register another promise. So we are just pushing the unresolved, which might be another promise. Okay, and in the catch section, we have a handling error. Unresolved we just go over a promise chain and would switch the storing value all the time. Since we have a chain, and on that we might have another function, then we have to resolve all of them and transfer the values. As you can see, stored values is always transferred into our next function. Okay, I have here a test with a fake server, and here I'm just I'm making a fake API call, and let's just run it and see how it's working. I would just disable all of my breakpoints. Sorry, that is a little bit. Let's just see what it, well, let's see what it made. So we're seeing that we have entered our test, and you know, all the promise has been executed. How our test is being written? So our test is being written in, let's just go over it. We're making an API call, and on that, we are just registering something else. Okay, so we're doing another function and another function, and our promise is just executing the entire chain call. So that was my session about implementing promises and what are promises and what is async await. I really hope that you found it interesting, and thank you very much all of you for listening, and it's been a pleasure.